Hi everyone, this is Vince from zkLink. I'm co-founder of zkLink. Today is my pleasure to present the new platform we're about to launch, zkLink Nexus, the first zero-knowledge proof-based multi-rollup layer 3. So zkLink Nexus is a new platform that is ZKP-based and unified layer 3 solution across multiple Ethereum layer 2 zk-Rollups. So what does it mean being a layer 3? Layer 3s are built on top of Ethereum layer 2 rollups, and the layer 2 rollups are built on top of Ethereum layer 1. And the layer 3s deliver higher scalability, lower gas cost, and it provides more application-specific customizability for certain types of applications. There are already some layer 3 solutions that you might have already heard of before, such as zkSync, Hyperchain, Starknet Madara, or Arbitrum Orbits. And these layer 3s are built on top of Starknet, zkSync, Arbitrum, their own layer 2 rollup. And these layer 3s will use the same tech stack as their layer 2s. So the major difference between the other layer 3s and the zkLink Nexus layer 3 is that zkLink Nexus layer 3 is a unified multi-rollup layer 3. It provides aggregated liquidity across these different layer 2 ecosystems, and it comes with aggregated assets across different layer 2s. So it provides users with more trading pairs, which means more trading opportunities. And also it comes with unprecedented flexibility. Also, there are additional benefits like cross zkLink Nexus Layer 3 rollup compatibility when you can actually compose transactions among different deployment of Layer 3 rollups. Because the essential idea of building a Layer 3 is that you only want you want the application specific layer 3 for your own application. You don't want to share the throughput and the resources with other applications. So eventually you could potentially maximize the performance, the throughput of the rollup setup. And also there are unique features compared with other layer 3s, such as multi-application recursive proof verification, which is a new design that we propose, and also a new feature like trading specific domain specific language, which we call also TS-DSL. It is a kind of script that gives the application builders more flexibility to build a certain product features, such as copy trading, such as social trading, grid trading, to build more feature-rich trading applications. And for zkLink's solution, this is a general overview. This graphic provides the architecture. This is the architecture of the layer 3. And it is on this graphic, you can see in the middle, there are three different layer 2 rollups, zk-Rollups, zk-EVM, and both zk-EVM and zk-VM. For zk-EVMs, you have here Linea and zkSync. For zk-VM, we have Starknet here. And on the bottom is the layer 3 platform of zkLink. And on the very top, it is the layer 1 of Ethereum. There is Ethereum contract deployed by zkLink on layer 1. And at the same time, the layer 3 platform, the rollup service on layer 3 commit states and zero-knowledge proof to the layer 2s. And then the state proofs will be sent to the Ethereum contract through the official bridge that these layer 2s deployed on Ethereum. And then the Ethereum contract will judge the consistency of the different states roots that the different layer 2s received from the layer 3 platform of zkLink. And then Ethereum contract will send the confirmation message back to the layer 2s. In this way, the multi-rollup state of synchronization is done indirectly with the Ethereum contract. Why is this step very important? because any multi-rollup or multi-chain infra will have the same security challenge, which is the deposit fraud. What does mean deposit fraud? It means that the validator can falsely inform one chain about a deposit on another chain, which they cannot directly verify, because multi-chain or multi-rollup infras, they are not able to, the different chains are not able to directly perceive the states of another chain. For example, Starknet cannot directly perceive the state on zkSync. So if the zkLink off-chain validator tells the zkSync contract that there's 100 USDT deposit on Starknet, the contract on zkSync will not be able to directly verify and get this information from Starknet contracts. Instead, it always relies on another third party to tell them this deposit information. So when you have a multi-rollup infrastructure, the possibility of deposit fraud occurs. And how to countermeasure this, how to make sure that all the deposit information is correct on each of these chains, because we will have all these assets entering zkLink's unified layer 3, and they trade with each other. So they have the contagion if you have a false deposit. This process is done exactly as the way I explained. With state root that contains all the information on the Merkle tree on the layer 3. This state root is sent to different layer 2s, and these layer 2s send this state root to Ethereum contract through the official bridge between the layer 2s and the Ethereum. And then the Ethereum contract will judge the consistency of the different states roots they receive from the different layer 2s. And if they're the same, means that the multi-chain, multi-rollup state consistency is confirmed. And in this case, you can always be sure that the deposit information is correct, and there is no way to do a false deposit and rob the other rollup assets. And this is the simple graphic that shows the security inheritance of any layer 3, including zkLink and Nexus. So the layer 3 inherits the security of the layer 2s through zero-knowledge proofs, and then the zk-Rollup layer 2s inherit the security of layer 1, which is Ethereum, with the zk-Rollup zero-knowledge proof. And through this, the layer 3s also indirectly inherits the Ethereum security. So you can almost say that layer 3s are being as secure as Ethereum. But this actually has a condition that the layer 2s will be mature, and they are trust minimized, which means that we will have to wait for the decentralization and the maturity of the layer 2s. At this point, we're still at very early days of layer 3s, because the layer 2s are not fully production ready. They're not fully decentralized. So we still need the layer 2s to be more mature to have the same level of security for layer 3 as Ethereum. And this is a diagram that shows the zkLink Nexus protocol key components. In the middle, you see that within the zkLink Nexus protocol, we have the broker surveys for liquidity to move liquidity to enable faster withdrawal and move liquidity among different layer 2s. And also you have the server call, which has there you have the executor and the prover service, and also you have the sender and watcher on layer 2s and the layer 1s. And we have different SDKs, the developer tools for application builders to facilitate and simplify their development work. And also we need to call the public or private RPC nodes to be able to access the layer 2, layer 1s. And on top of zkLink platform, you will have different types of decentralized applications, including spot perp trading, RWA derivative trading, NFT minting, NFT trading, etc. As you can see from here, that the application types that we right now supporting are very much focused on trading. there are 4 key functions that we want to highlight. These 4 different functions we consider to be very important and helpful for dApp builders to simplify and facilitate the dev work. The first one is native ZK social login. Why is it important? It comes with account abstraction, of course, and with this function, dApp builders will be able to build the product features that to allow their users to log on to their platform with their social accounts, with email account, for example. And the reason we're building this and not directly integrating a third-party AI service is because we want to minimize the trust assumption for this AI service. For example, if we want to use Web3 authentication from a third-party service provider like Particle Network or like Web3 Auth, then they still store the shards of the private keys of their users on their own service, which is not ideal. So you have at the same time the trust assumption on the social accounts, which, for example, is the Gmail is your Gmail account, and at the same time you have to trust the service providers that they can securely they can store the private keys and secure these private keys. But yeah, this is we don't want this additional security assumption. So we want to develop a native ZK social login function which only have one trust assumption, which is the social login, the social account. We also provide user deposit manager SDK to the app builders, so they can enable the function of deposits that matches exactly the same user experience of CEX, which means it's from end to end. Users will no longer need to have a wallet address. First, they can generate a wallet address with their social account, and they can directly transfer their funds from a CEX to a DEX without having to sign for the transaction, without having to buy a gas token in advance, without having to select the chain. A ZK Oracle Hub is the second key function that we develop for our dApp builders. What it does mean for perpetual contract trading, for perps, especially for order book perp trading, we always need to have high frequency, low latency price feed from oracles. And if you feed the price each time and you do verification on the smart contract to verify the signature of the price feeds, it will be very expensive because it's high frequency. And so we want to reduce the cost of this verification by doing the price signature verification option and use zero-knowledge proofs to prove this verification process, and then sends this proof together with the price feeds on chain, and then the on-chain contract just need to do once instead of 100 times. So this will significantly save the cost for per order book trading products. And this feature also provides enhanced programmable price filtering function to the dApp builders. For example, with this aggregated price, then the application builders will have the possibility to enable some features on these price feeds to protect their traders. This will be very effective and helpful for smaller FDV tokens when we often see radical price fluctuations. And then the app builders can enable some certain price features to say, let's filter the extreme price fluctuation to protect the trader under certain kind of extreme market condition. And this provides higher transparency and higher stability to the perp markets on these DEXs. The third key function is the adaptive liquidity rebalancing. Why this is needed? This adaptive liquidity rebalancing is certainly not needed on a layer 3 that is deployed on a single rollup. But if you have a layer 3 deployed on top of multiple layer 2s, then you have liquidity movement from one layer to another. So some of the time you will see, for example, user funds or liquidity moving from, for example, stagnant to zkSync or the other way around. And then the users that want to withdraw the funds to zkSync will have a problem because there might not be enough liquidity there. Then you need to rebalance the liquidity. The total sum of the funds will be equivalent, but you can have much more funds on one chain or one layer 2 compared to another one. So that for these types of needs, we provide rebalancing tool for multi-chain tokens such as Ethereum, such as stables, USDC, USDT, or other algo stables that are that are native on multiple layer 2s. Function is liquidity broker service. This is very important for user experience because for any ZK rollups, any ZK rollup layer 2 or layer 3, the finality time, although we believe that the finality time of layer 2s will be significantly faster with the maturity, with the progress of layer 2 as a whole, but still they might take hours to verify on chain, to batch the transaction and generate proof and verify the proof on chain. But what if a user want to exit their funds to layer 1 more quickly than that, quicker than that? Then you probably want to have liquidity broker that can transfer the funds to you once you make the request, and the brokers can wait for the verification to be finished and receive the funds back from the smart contract. With these 40 functions, we believe that we will be able to greatly help our developers to simplify their work and save their development cost, and save their time. And this is also one important feature of the architecture of zkLink layer 3 platform. It comes as modular solution, which means fast and flexible integration. Yeah, there are two aspects of modular solution customizability. One is the customizable data availability deployments. As the layer 3 is deployed across multiple layer 2s, you can choose one of the layer 2s as data availability layer, or you can use external data availability layer like EigenDA or Celestia, or you can also organize, a layer 3 can organize their own data availability committee, DAC, or they can choose to certainly post their DA on Ethereum. This totally depends on the type of application that you're building, and also depends on the cost effectiveness that you want to have. And for business reasons, you could have the DSA, or there's external modular DA layer like Celestia, EigenDA, although they are slightly more expensive than DSA. And then you have ultimate DA solution, Ethereum, which is considered to be the most secure one, most reliable one, as Ethereum full nodes are most decentralized. And also the second aspect of the modularity of the layer 3 platform is the customizable network collections. So some application might say, I want Ethereum, I want zkSync, I want the Stuxnet, I want Linear, I want Tyco, I also want Polygon ZK EVM, I want every ZK EVM available from the market. Yeah, that's fine. Another type of application, which is maybe more focused on a demographic region, or focused on a different group of users, they may say, okay, I only want Stuxnet, zkSync, and Scroll. Why not? So you could have the one to many, any collection, network collection, as for your business use case and for your specific needs. The zkLink layer 3 platform has done a lot of work to provide enhanced performance to the applications. There are a few key points that we have listed here. The first thing is the Poseidon hash adoption. Poseidon hash as a new hash function provides excellent performance and security, and it results in faster hash computations. This is relatively speaking compared with secure hash that we used to use in our implementation. And the second in optimization we've done is circuit executors refactoring. We've done quite many extensive optimization and refactoring of the zero-knowledge circuits that we developed. Because we are application-specific layer 3 platform, the approach that we're taking, that we write the circuits for each of the opcodes needed for the use cases that we aim to support. So the circuits we are spending a lot of time and efforts on the optimization of these specific application-specific zero-knowledge circuits. And the third point of our optimization is the parallel processing innovation. We have done some deep work there for the server core to be able to parallelize the processing of the ordering there, and accelerating the awareness generation, maintaining efficiency during high transaction volumes. And also currently we're exploring the possibility to implement the new proof system. We have done internal benchmark work with Nova, Hypernova, and Supernova. The folding scheme is very interesting for our implementation because our circuit is a mid-sized circuit compared with type 2 or type 1 ZK EVMs. For one opcode, our circuit is actually slightly bigger compared with the opcodes on ZK EVMs, but at the same time, the total scale of the zero-knowledge circuits of zkLink is significantly smaller compared with ZK EVMs, because for ZK EVM, you need to build hundreds of opcodes, but we only need like 10, 20 opcodes for the use cases that we support. We're actively contributing to the Nova implementation because we're still early. There still a lot of work to be done there. We will open source our work once it's ready. This is also something that I'd like to talk about, which is the multi-application recursive proof verification. Why this is needed and why this is interesting, because it can significantly reduce the cost of the verification, zero-knowledge proof verification on chain. There are two parts. There are many two parts of the cost when you operate a zk-Rollup system: the proof generation and the proof verification. Oh, actually, the proof verification together with the DA. So you could also say that there are three parts: proof generation, proof verification, and DA. And here we consider the proof verification together with DA, which is with the data we post on chain. And for the off-chain part, the proof generation part, by our estimation, it takes roughly 30, maybe 20 to 30% of the total cost of the operational cost of a zk-Rollup. And the on-chain cost, the DA and the verification, takes another 70 to 80%, which means that the on-chain cost is still is still higher than the off-chain cost. So we think a lot about how to optimize the cost of the verification and also the DA. For the DA cost, as I explained, there are different types of implementations and deployments possible for different types of use cases. For DeFi, they probably want to post the DA on Ethereum, or maybe another slightly like another solution that is not as secure as Ethereum, but it could be very close to Ethereum, like DA, or a new type of application, maybe NFT trading or a gaming platform that has game assets, a lot of game assets, might not need as a much high level of security for the DA. They probably need more like retrievability from for their assets, rather than to reconstruct the full state of the state tree of chain. Then for the DA, you have different solutions to meet diverse demands, to reduce the cost, to find the best balance between cost and the security you want. And for the zero-knowledge proof of verification, if we will be able to bring down the verification times in total, then we'll be able to bring down the total cost of zero-knowledge proof verification to operate the system. Because each of the verification takes roughly the same amount of gas, consumes roughly the same amount of gas. So if we could do less verification times by using recursive proofs, this would be very interesting for any types of application that be able to use this. So on zkLink's Nexus platform, we are implementation the MARPV, multi-application recursive proof verification, designed by ourselves. And also we'll be providing a developer-friendly trading-specific DSL, domain-specific language. It comes with a lot of benefits, such as improved efficiency. So the traders that want to do certain types of trades will be able to do algo trading, copy trading, grid trading, and this will unlock new types of user experience on DEXs, which we have never seen before. It also empowers the DEX builders with less complexity when they compose the product using DSL. If you compare DSL with programming language, and DSL is this type of script that is a lot easier to learn and a lot easier to use. So this will be more cost effective for developers. And also the DSL adaptability makes the strategic trade more flexible and more cost effective for the traders. And the DEX that can implement complex trading strategies with this TS DSL. I've been talking about the technology and implementation a lot. Right now, I want to talk a little more about why we're doing this, why we're building a unified layer 3 platform across layer 2s. What are the benefits? Why would developers care about this layer 3 platform? Why would the users care about this layer 3 platform? The benefits are many. But out of the many benefits, the most important are still the core vision of zkLink. We want to empower the next generation of products with the best user experience possible that can match and compete with centralized platforms. When you go to Binance, when you want to do a trade on Binance, you don't really think about which chain you are using, right? You make a deposit to the platform, and then you buy any token that is listed on the platform, and then you can park the funds there. You can withdraw funds to a chain or to another wallet. through many different chains. For example, you can make a transaction of stables through 3 or 4 different chains. The user experience has been very intuitive, but the user experience on DEXs nowadays is still very broken. But with the zkLink's unified layer 3, developers will be able to list the token across multiple rollups and enable the trading of these native assets. There's no wrapping process of these tokens, as these tokens are locked in a smart contract and then mapped to the layer 3 platform through the zero-entry proof zk-Rollup system. This is not only for fungible tokens, but also for non-fungible tokens, NFTs. And this will unlock more abundant trading opportunities for the users on DEXs. And also, a user can manage their portfolio of their multi-chain token portfolio using one wallet on a unified user interface. And yeah, another important aspect of this solution is that this unified layer 3 will be much needed as the liquidity fragmentation becomes more of a problem when layer 2s grows bigger than today. Each of the layer 2s will have their own liquid system and will have the users. And users go to each of the layer 2s, they will need to bridge their funds over. And the more layer 2s, the more rollups we have, the more liquidity fragmentation we're going to see. And the liquidity silos on these rollups needs to have, we would need either we use quotient bridge to move the funds liquidities among these different layer 2s, or alternatively, an application can deploy on zkLink layer 3 and access to the liquidities on different layer 2s. So this will greatly simplify the user experience, because any user can enter the layer 3 directly from Ethereum, or they can enter the layer 3 from any layer 2. And once they enter, different users from different ecosystems enter to the layer 3 platform, you have aggregated liquidity on one unified platform, one unified user interface. For the tokens that exist on multiple chains or multiple rollups, such as stables or Ethereum, the tokens entering layer 3 from different layer 2s will be merged to the same token, just as shown in this graphic, right? And so the liquidities are merged to a single token, and you have like deeper liquidity on this single trading pair. Think about the DEXs that of today. If you bridge a token from BNB chain, for example, to Ethereum, it will be a different token because it is wrapped. And by doing so, zkLink layer 3's platform will be able to unify liquidities of these stables or multi-chain tokens, and also aggregate the liquidities from different types of assets. And by theory, we hope that the next generation of DEXs will be able to serve millions of traders, will onboard millions of traders. And the more liquidity you have, the more aggregation you have, the higher capital efficiency you can have there on the DEX. So the conclusion here is zkLink want to be the first across Rollup layer 3 to unite the Ethereum layer 2 ecosystem to help onboard the next billion of traders on chain. If you want to learn more about the solution and the platform, you can visit our website and go and also follow our Twitter. There will be up-to-date information about these new exciting launches of different features that I just discussed here. Thank you very much.
Very good, Vince. Thank you so much for presenting. This is very informational. It kind of like opens my mind to the mental model of the Omni chain that I think we heard about for quite a while as like some of the layer 1 started to pop up. And then we kind of continued to fragment the block space a little bit further with layer 2s. now even further with layer 3s, but then we're getting these interoperability solutions to link them all together. I'm curious, in general, like, is zkLink the omni-chain mental model? I guess I'm curious in general, how do you picture this block space? Do you think it continues to fragment, or do you think we continue to unify it? What is your mental model for block space?
It's actually a very good question. There are builders a lot of builders building new layer 2s, new rollups. We're probably gonna see hundreds, even thousands of new rollups in the next few quarters. At the same time, we have another group of builders that want to combine and aggregate and unify these new rollups, right? zkLink is one of the builder team that wants to connect, wants to unify the liquidity fragmentation, wants to abstract the complexity among these hundreds of rollups, right? So, and we want to solve the problem from different angle. There are a lot of teams building crossing bridge to facilitate user funds transactions from one chain to another, one rollup to another, from layer 1 to layer 1, layer 1 to layer 2, layer 2 to layer 2, layer 2 to layer 3, maybe layer 1 to layer 3. We'll see a lot of bridge for sure. But for some applications that are already on layer 3, we think it is very interesting for them to have a unified environment across multiple layer 2s. This greatly simplify the user experience. They save a few steps for user. So they no longer need to use a crossing bridge. The current crossing bridge is still costly and is user unfriendly at some point. And if you have the user coming from different chains on one unified user interface, then the users don't really have to care about which chain they're using or which rollup they're using, and then they will be able to trade. They just want to do the trade. This is also kind of like user-centric approach, user experience-centric approach. And back to your question, I think the future of blockchain is, for me, is evident that it's going to be multi-chains and multi-rollups. Horizontally, there will be multi-chains, and vertically, there will be multiple layers and multi-rollups. There will be many layer 2s, and there will be many layer 3s. With more applications, getting users onto their applications. A lot of these successful applications will ultimately need to deploy their own rollup on layer 3, very likely, or some of these will also maybe adopt some other approach, like DYDX going to Cosmos, building their own application chain. And we'll see the layer 3 application, specific layer 3s, will be competing with some of these Cosmos layer 1 app chains. Either way, I think this will leads to a future that there will be a lot of chains and a lot of rollups, and we definitely need the solutions to address to the fragmentation of liquidity, address to the interoperability, and every step we simplify and save for the user will help us to acquire more users.
Yeah, I was curious on this slide here. On the liquidity aggregation, since these are all zk EVMs, like Linea
or
Tycho,
zkVMs, general purpose zk.
Yeah, I believe that they all share the same kind of properties in that they use the same code base, like geth and opcodes and different things. But there are definitely slight differences between Linea's model and Tycho and zkSync. So how do you guys, from the tech side, what are you guys doing to be able to aggregate different types of, whether it be opcodes or ZK provers, or for example, Tycho, they're not going to have a sequencer. They've got this interesting model, right? So how are you guys able to, on the back end, kind of aggregate those and build atop each different tech stack, abiding by the slight differences and keeping safety, privacy, and decentralization in mind?
Thank you for your question, Andy. This is a great question. So to answer your question first, the liquidity aggregation has nothing to do with the tech stack, because the tokens they have, like in ERC20, that's similar, so they all have they are the same token. So the Ethereum on this Tyco, on Linear, on zkSync, on Starknet, they are all deposited Ethereum from Ethereum. They are not issued on these layer 2s. They're not a native token on these chains. So they are Ether locked in the smart contracts on Ethereum and enter the layer 2s from Ethereum layer 1. And then for these Ethers can enter to layer 3, zkLink layer 3, and they will be merged to Ethereum. That the total sum of the tokens will be strictly equivalent to the the tokens locked in the smart contract on layer 1 ultimately, right? So we don't need to differentiate this Ether from different layer 2s. It's the same for stables. As long as this stable is issued by the same entity. For example, USDC is issued by Circle on different layer 2s. They considered to be the same, and you can directly merge them. But careful, we don't want to merge USDT with USDC because they are not from this entity and they have the price variation there. And we do have considered a lot about the stable to eliminate the disparities among different types of stables. But this is quite risky. And for the second part of the question is the tech stack difference among different ZK EVMs. There are 4 types of EVM, roughly type 1, 2, 3, 4, and also ZK VMs. There are more different ZK EVMs in the future. And how do we eliminate the differences and on different ZK zero-up layer 2s? The answer is that we do not. We actually build and we write the zero-knowledge proofs verifications contract in Solidity on ZK EVMs, and then in Cairo on Starknet, or there may be a new zkEVM or the new zkVM maybe will come up with a more efficient or new language, and then we will write our verification contract in that new language, and we deploy this zero-knowledge proof verification contract on these ZK EVMs and the ZK VMs, and we post the states and the post the DA and post the proof to these contracts. So by doing so, the developers, the application builders on our platform will no longer to build on different layer 2s and learn different programming language and use different develop tooling. Exactly, this is our part of our core value proposition to facilitate the development work for application builders. We do the heavy lifting, heavy engineering development work for them on the back end, and then they focus on the front end, the consumer-facing, trader-facing, the product features, financial product design, liquidity management, user acquisition, assets management, and listing. They build the user-facing features. They build a product that is easy, smooth, intuitive, that users love. And we facilitate the work on the back end for them. We do this hard work on zero-knowledge proof circuits, there is ZK circuits developments. We build across different ecosystems, and they just need to connect to zkLink with our API with JavaScript, very easy and low cost in development. And yeah, we think this is very valuable for DEX builders, and we are solving the real problems that they're facing today on a daily basis. We have talked to quite many developer teams, and they love the value proposition here, love the solution, because we solve real problem and we save cost, save time for them.
Certainly. Yeah, the shared liquidity model is a win-win for all of these decentralized exchanges because they can pass capital efficiency and better prices to the end users.
Exactly. User experience on the DEX means the price. Ultimately it comes down to the liquidity and the price you can have. If you can provide the best liquidity, you have the best price, and then you will have, for sure, will have traders.
Amazing. Vince, thank you so much for coming on. I think we're out of questions now. I'm just going to pop up the last slide here for anyone who is curious to check out your website and your Twitter. Again, thank you so much for coming on. Is there any closing thoughts or anything else that you'd like to share before we roll it up?
Thank you very much, Robbie. Yes, maybe just one more sentence, maybe a few more words on layer 3s in general. As I already mentioned at the beginning of my sharing, that we're still at the very early days of layer 3s, because now people are still talking about layer 2s. We're still waiting for the layer 2s to be fully production ready and user ready. The user experience and the cost to make a transaction on the layer 2 now still pretty broken, right? And we still need more work to be. We're waiting for the layer 2s to be more user friendly and decentralized. Ultimately, with decentralized approvers, decentralized sequencers, and with battle tested zero-knowledge circuits, and then the layer 3s will be. We'll be able to say that the layer 3s will be strictly inheriting the security of layer 1, because layer 2s in the middle, they are very important for the success of layer 3s. So we hope all the best for the general purpose layer 2s, ZK EVMs, ZK VMs, and we're definitely bullish on the future of this ZK EVM and ZK VMs. They will build we believe, we're bullish that they will be able to build prosperous ecosystem with the technology, because zero-knowledge proof solve the problem of security scalability, and we will help to scale from there on top of their platform. And we are excited for the future. Thank you very much.
Yes, sir. Thank you, Vince.
Thank you, Andy. Thank you, Robbie.